All right, Math 1, Unit 2A, Section 3, Axis Reflections with Graphs. So this one, like it sounds, we're going to be reflecting things over an axis. So think about whenever we reflect, we kind of like flip it over, right? And we're flipping it over, in number 1, we're going to be flipping it over the y-axis. This is the y-axis. So we're going to flip the shape over on that axis. This means that if you're doing on the y-axis, nothing moves up or down. It just moves left or right. So I think the easiest way to do this is to take a point. We'll take point E first. I think that would be easy. It's 1 unit away, and you're going to count 1 unit in the opposite direction, and you're going to put your new E. Actually, let me write it above there. And I'll make it E prime. Now let me erase my E points, or my E lines. Now for D, D is 2 units away, so I'm going to go 2 units away. Here's D prime. C is right below D. It's 2 units away, so it goes right here, right? Here's 2 units, here's 2 units, so here's going to be E prime. And then F, we look and F is F is 3 units away, so I'm going to go 3 units this way. Here's going to be F prime. Now that I have the points, I'm just going to connect the dots. And we should be able to see that it's just a flipped over version of it, right? Just for future reference and to be able to understand it better, this point F right there, that is at the point 3, 4. Point F prime is at -3. Oh, it's -4, I'm sorry. 3, -4, and -3, -4. Notice that the only thing that changed was the x value, the left to right value, right? Now that can get kind of confusing because we're reflecting over the y-axis, but the x is the one that changes. Our formula, like how I had the point formulas for last time, this would be -x, y, where the y stays the same and the x flips. So for a y-axis reflection, there's your point formula, or your formula point, whatever you want to call it. Let's look at number 2. We're reflecting over the x-axis this time. So the x-axis is the horizontal axis. I'm going to do it the same way that I did number 1, only this time instead of counting left to right, I'm counting up to down. So we'll start off with point R. So R is 1 unit away, so it's going to be 1 unit below. Q. Q is 3 down, so now it's going to be 3 up. So Q prime. We'll do S next. S is 3 up, so I'm going to go 3 down. Here will be S prime. That looks like a 5, doesn't it? S prime. And then T prime would be right there. I connect my dots. And there's my shape. Just like last time, I want to look at what happens to our actual points, like what happens to the value of our points. Let's look at point S. S is at 5, and then what is that? Is that up? 1, 2, 3, 5, 3. S prime is at 5, -3. So we reflected over the x-axis, but the y is what flipped. And again, just like in last time, that can be kind of confusing. Sometimes you want to flip those around. The formula for reflecting over the x-axis would be x -y, right? And the -y just means flip it. So if it's positive, it makes it negative, and if it's negative, it makes it positive. All right, let's look at number 3. We're reflecting over the y-axis, so I'm going to put a little line here to remind us what we're doing. Maybe I can draw a little bit better than that. There we are, not half bad. F, we'll start with F. F is 2 to the right, so we're going to go 2 to the left. There's F prime. I is 5 to the right, so we're going to go 5 to the left. G is 2 to the right, so we'll go 2 to the left. And then H is 5 to the right, so we'll go 5 to the left. And there's our shape. That one's really easy to see, that if you took your paper, right, so these would be symmetric. And they'd be symmetric based off of the axis that we have there. And what symmetric means is that you could take, if you had this actually printed out in front of you, and you guys do, and if you wanted to, you could fold it and they would line up perfectly. Now, we're not very good artists, or at least I'm not, so it wouldn't actually go perfectly, but it would be really, really close. And that's the big deal here, the big idea here, that you could fold this up on that blue line, on this blue line here, the y-axis, and they would touch each other. And that's what a reflection is. Reflections create symmetric things, or symmetric figures. All right, number 4, we're another reflection over the y-axis. So here's my y-axis. Oh my goodness. There we are. Let's start off with R. R is right there. It is on the y-axis, and we're reflecting on the y-axis. If a point is on the line that you're reflecting, it doesn't move. Okay? So this is going to be R prime also. Same idea with Q. This will also be Q prime. Now our last point P is actually going to reflect. It'll go all the way over here, and then we can connect the dots. And here again, just like in number 3, it's really easy to see that if we folded along the light blue line there, they would perfectly touch each other, or perfectly line up. So remember, the big deal about this problem here is that if a point is on the line that you're reflecting, the point doesn't move, right? The regular Q and Q prime, R and R prime are on the same spot. All right, let's look at number 5. Oh, that doesn't look right. Let me, what is this? This is section 3. Let me see what the paper should say. Well, that one looks wrong too. All right, so we're supposed to be going off of the y-axis. Your paper should be right. I don't know why mine does this sometimes. And this should be 0, -2, 2, 3, 4, 2, and 5, -3. I'm just going to go through really quick and fix all of these. All right, I'm sorry. I didn't realize that I don't know why it messed up that way. You'll notice, I don't know if you paid attention during that, that all 4 of these are dealing with the y-axis. There's nothing special about the y-axis. It's just that these 4 problems that were randomly generated randomly came to all be y's. So don't think that there's anything special about it. So your paper should look a little bit better than this. We're reflecting on the y-axis, and there are our points. I don't know why they have little apostrophes there, but they do, and we're just going to deal with it. So we're reflecting on the y-axis. For the directions, what do the directions say? We're supposed to graph the image of the figure using the transformation given. So we don't care about the original, we just care about the new one. So what I would do in these is I would say, well, we're going off the y-axis. So what is my point formula? My point formula would be -x, and then the y stays the same, right? We're going back up and we're looking at right here. Whenever we go over the y-axis, we use -x, y. So I could really quickly write down all of my new points. So k prime, my 0, I plug in and I have, well, -0, which is just going to be 0, and then -2. For L prime, I'm going to have a -2, 3, right? All I'm doing is I'm switching the sign of the x. M would be -4, 2, and N would be -5, -3. Now that I have my new points, I just need to plot them. So 0, negative 2 will be right here. That's K prime. L prime will be at right there. M prime will be right here. And N prime will be down here. I connect the dots. And there we are. All right, number 6. Again, we're doing the y-axis, so I want to use the formula negative x, y. And again, I'm going to start off by writing my new points down. So I have E prime, F prime, and G prime. E prime, I switch the sign of the x, so it's going to be a negative 1, and then the y stays the same, so negative 5. The 2 will change to a negative 2. The 4 will change to a negative 4. And we haven't had an example like this yet, but if this G here was a negative 4, it would turn into a positive 4. It just switches the sign. So plotting these, I have, there's E prime, F prime is at right there, and G prime is here. So I connect the dots. This should look like that. Something that helps me do these problems quickly is knowing that CUDA always uses a 5 by 5. So you can always know that this piece here is always going to be 5 units. You can always count it, but I think it goes a little bit faster if you just can kind of know that they're 5. So the way that I did like the G prime down here is I said, well, this is 5, so this has to be 4, rather than counting over 4. That's just a trick that I use with the CUDA problems. You're welcome to do anything that you want. You can just count over if you'd like that. Moving on to number 7. I know the points are kind of wonky, and I apologize for that. I'll try to make sure that it's fixed for the next lesson. So we're reflecting over the y-axis, and here are our points. The y-axis, again, our point formula, or our formula point, whatever we want to call it, is negative x, y. Our x changes to be negative, or negative to positive, and our y stays the same. So let me first write u prime, v prime, w prime, and x prime. And now for my points. U is at negative 5, 0. So I'm going to change the sign of my x. Well, x is negative 5, and the opposite of that, the flipped sign of that would be positive 5. So it'll be 5, 0. V is at negative 4, so it's going to be 4, and then 3. W will be 2, 0, and x will be 3, 5. I go to graph these now, and I have, well, 5, 0 is going to be u prime. 4, 3 will be v prime. W prime will be 2, 0. And x prime is at 3, 5. And so our shape should look something like that. All right, number 8. Again, we're reflecting on the y-axis. And actually, you know what? Let's do x-axis. Cross out what's on yours, and we're going to say x-axis. For the x-axis, it's a different formula. And that's why I wanted to do an x-axis example. It's going to be x and then negative y, right? On the front page, I wrote something down about this. So I'm going to, just like the last one, I'm going to write down my prime. So I prime, j prime, k prime, and l prime. My x stays the same, so it'll be negative 3, but my y changes signs, so it'll be a negative 2. J will be negative 2, negative 5. K will be 0, negative 3. And L will be negative 2, negative 1. The only thing that changed was the sign of the y, right? They should all be different than the original. So now to go plot these, I'm at negative 3, negative 2. There's my I prime. J prime's at negative 2, negative 5. K prime is at 0, negative 3. And L is at negative 2, negative 1. Connecting the dots gives me that little trapezoid thing. All right, there we are.